So we are going to see some classical attacks that have occurred in the past, and then we are going to see some defense mechanisms to protect ourselves against such attacks and many other attacks that could be possible. So the classical attacks typically, or even like if you want to do any sort of attack from a network security point of view, let me increase okay. So the first thing you have to do is what is called reconnaissance. So reconnaissance is nothing but you are planning for an attack or preparing for an attack. So if you want to really do any attack, okay, so it may not be even just network security, any sort of attack, you have to plan for it. If you just do an attack without any preparation, it's easy to get caught, and it's easy to be detected, and there will be an easy solution for the victim that you're targeting. So that's why you have to plan for an attack. Okay, that's a typical strategy for an attacker. A typical mechanism that attackers do to plan for an attack is do what is called port scan. And you all know what's the port number from the earlier modules. So all the applications that you run on your machine host will run on certain port numbers. So the port numbers are like the open doors in your house or windows in your house. So an attacker can get into your house only through this open port or windows, right? So if you don't run any application in your computer, means all the ports are closed. That means all your doors are closed, all windows are closed, so nobody will be able to enter your house. So the attackers will try to find out what ports are open in your machine in order to plan for an attack. Okay, so typically there are a lot of tools available called Nmap and Netcat and all these tools. Most of them are free. So you can run these tools on a targeted machine, which means you can run it remotely. So you can pass the IP address or website address of those machines or servers and run these tools from remote, from some other machine of the attacker site. And through this port scan, what you can really find out is what are the open ports and services you're running on these ports, okay, and what operating system is running on that victim or the target you're trying to attack, and the applications that are also installed on that machine. Now these are the typical entry points, because the applications again that you have installed on that machine will give you some idea about what vulnerabilities are associated with those applications, because not all applications are developed. Every application will have some kind of loophole for an attacker to exploit. Similarly, all the services that you are running, say for example you are running an Echo service to respond back for any ping request, or any type of service that you are running will have some kind of vulnerability that could be exploited. Or the attacker could research on that service and our application and see what could be a new vulnerability that has not been found so far but could be found and exploited. So this is a kind of research area. The attackers also do a lot of research on these things, and so using this they'll try to decide how to prepare for an attack. Okay. Now the port scan again will also is also done on, not only is typically done on server machines that are typically the targets for an attack, because you want to bring down the service provided by that server machine to the regular clients. But you also want from an attacker also wants what is called an agent. So it's typically called a zombie. So a zombie is kind of like a compromised machine that will serve as an agent for the attacker. So again, an attacker typically with all the technology developed so far would not like to attack from a single source, because we can trace back the attack to the source from which the attack is originating. So these days attackers try to do what is called distributed attacks, in the sense that the attack will originate from several sources simultaneously, and it's difficult from a trace back point of view to trace back to a particular source from which the attack is originating. So in that sense, the attackers will try to do what's called IP spoofing, in the sense a packet will appear to come from a particular source, but that source, because when you look at the packet, the IP address will correspond to some particular host, but that host would not have really sent that packet. So the attacker might have sent the packet from his own machine, but would have spoofed the IP address to make it to appear to come from a different host. So that host could be a zombie, because the attacker would have found that that host has some vulnerabilities that could be exploited and could made to serve as an agent. Okay. So recently, these days you get phone calls from numbers, and when you pick up the call, nobody answers that call. And a few days back, I got a call from a number, and I called back that number, and one person picked, and I said, I got a call from your number. That person said, I did not make any call, but I got that call from that number, so I called back the same number. So it looked like, for me, it shows up that some number from which the call is coming from, but actually the call was made to me from some other number. So that's the same thing here. So the packet would appear to come from a particular IP address, but the host corresponding to that IP address would not have sent that packet. So that's called IP spoofing. And later we're going to see some classical attacks that could be done by using IP spoofing. So the nature of the attacks that we're typically going to see is kind of what's called a distributed denial of service attack. So first of all, what is a denial of service attack means? So as I said, it's typically the servers that are being targeted. So you want to bring down the servers so that they do not provide the required service to the genuine clients. An example like that is, for example, you call the doctor's office and do all some fake appointments and fill up all the time slots. Then the doctor's office is full with all the time. So when a genuine client wants to get an appointment, that person is denied service. So of course these days the doctor's office wants you to call back within a couple of days before the visit and confirm the appointment and so on. And all these things are actually to kind of measures to prevent some denial of service attacks. So in the network security point of view also, the attackers could target the servers and try to kind of make them get the resources exhausted. And we'll see some examples where we could really see that the servers are really brought down, so they could not provide genuine service. So that's the kind of nature of the denial of service attacks. Now you want to, again as I said before, you don't want to launch these attacks from a single source, because it's quite easy to be traced back to that single source if you do it from a single source. So you want to first form what is called a network of zombies. So sometimes it's also called a botnet. Okay, so the zombies are the agents that are going to stand out and launch the attack, but the users working on those zombies may not even know that their machines are compromised and serving as agents. So the attacker, what they will try to do is, there is some kind of software malware called Trojan horse. So they will try to install the Trojan horse software on your machine, and it comes in the form of what is called a rootkit. Rootkit means it will conceal that your machine has been compromised, and it will, when you run even some anti-malware program, they will not be able to find out the activities done by the rootkit, and they will be silently running, so that's a kind of a Trojan horse program. You don't know that your machine is being compromised and serving as an agent. So the attacker will form a network of such agents, so that's called the botnet, and the attacker can still control things from a single machine. So he will now control the agents or the zombies, and once he forms a sufficiently robust botnet, then he will launch the attack on the victim machine. So the attack packets will appear to originate from the zombies, and it's a distributed attack in a sense that each zombie will not send that many attack packets, will send only few attack packets. So if you look at from a single source point of view, it will look like a normal traffic, not a very abnormal traffic coming from a particular source. But the attack packets will originate from several such sources and target a victim machine and bring it down. So that's the nature of typical nature of a distributed denial of service attack. Okay, so we'll see some examples now, so that it becomes even clearer what we mean by all these things. So a very classical attack is called the SYN Flood Attack. So we saw the TCP connection setup mechanism in the previous module, where you'd go through a three-way handshake. So the client sends a SYN request message, and the server allocates some resources like the buffer, windows, space, and all these things, and sends back a SYN plus acknowledgement packet. That's the second packet sent back as part of the connection setup mechanism. And then the server really expects the client to acknowledge for that SYN plus ACK as a third packet. So we saw that in the earlier module. You do a three-way handshake. So how this could be exploited? So the attacker could send several SYN request messages that appear to come from different spoofed IP addresses, like typically these zombies. So each zombie will send several SYN request messages to a particular server trying to open up a TCP connection. And for each such resource, the server could allocate some resources and send the SYN plus ACK packets, waiting for the response from those initiators, which are those zombies. But the zombies won't respond back, so they'll just initiate the connection request, but they won't kind of complete the connection setup process and exchange any data packets. So what the attacker wants is to tie up the resources of the server, because for each connection request, the server is going to allocate some resources, the buffer space typically. And so once all the resources have been allocated for this connection request, a genuine client trying to establish a TCP connection to the server will be denied service because all the buffer space is tied up. So that's the kind of denial of service attack. So the server will wait for some time, and if the connection is not being set up because the third packet has not come back from the initiator and no data packet has been exchanged, then the server will tear down the connection and start providing service to the genuine client. But by that time, the attacker would have accomplished what he wanted. He just wanted the server to be able to deny service to some genuine clients and bring down the reputation and so on. So that's the kind of nature of the distributed denial of service attack here. Okay. So any question before we continue? Okay. So let us see some more distributed denial of service attack. So another attack is called Smurf Attack. And we saw kind of this, what is the technical thing behind this in the first module. We saw it is called a targeted broadcast address in module 1, in the IP address topic. So a targeted broadcast, for example, if the network is 143.132 and the targeted broadcast address for that would be 143.132.255.255. At that time I told that we cannot send a data packet with the destination IP address being a targeted broadcast IP address. That means from some other network I cannot send a packet with the destination address as 143.132.255.255. I said the routers in the internet are going to drop such packets. The reason is this. So before this routers were disabled to do so, an attack like this has happened. So that's why the routers are now disabled. So let us see first the attack and then come back to what I was talking about. So an attacker again tries to send an echo request message. So he wants to bring down the server, the victim. So he sends a echo ping message. Ping message means he wants to test whether the server is alive or running or not. So he will send a ping echo request message such that the sender IP address of that ping request message is a broadcast address. Okay. So if this is, say, the 143.132 network, so the sender address will be 143.132.255.255, and it will be sent to this server. So again, the ping protocol, the thing is, if you ping some machine, it's going to respond to you back. So it's called echo request reply process. So you send a echo request message, whatever, and put some dummy message of 40 bytes or so in the request. The victim, that whoever the machine you're sending to, will respond back as an echo reply. So now the victim is going to respond back, but to who? To whoever sent it. But look, think about it. What is the sender IP address? It's the broadcast IP address. So the victim will send it back to the broadcast IP address of the network. Okay, so that means it's going to get a lot of such ping request messages from every host in this network. And not only that, here both the victim as well as this network is targeted, because you're going to get back the reply message to all the machines in the network. So that means the network bandwidth is also going to get exhausted. Okay, so here the attack is targeted on both the victim and a particular network. So you're going to get a flood of echo request messages, all targeted to a particular victim, and then you're going to get a flood of reply messages coming to all the machines in the network. So in order to prevent this attack, that's why the routers that are in between the victim and the network are going to drop any packet that has a broadcast IP address as the destination IP address. Okay. And if the server is running in a particular network, there we'll see later firewalls too. The firewall running at that network should be able to detect the source IP address of the incoming echo request packets, and should be also able to drop them if they appear to originate from a broadcast address. Okay, because the source address should be typically a unicast address. It cannot be a broadcast address. So if a firewall detects some abnormal addressing like that, it should be able to drop such packets too. So those are the solutions to prevent these attacks. Now another type of attack could be called an Echo-Chargen Attack. So like the ping protocol, the Chargen protocol is also a protocol that could be used to test whether a machine is alive or not. Now the Chargen protocol could run on either TCP or UDP. So and it typically runs on port 19. So if you use a TCP, if you run a TCP Chargen, and if you send a message to that port running a TCP Chargen protocol, it will keep on sending arbitrary characters to the sender, to the connecting host, until the host closes the connection. So that's done typically to test whether the server is alive, running or not. So the initiating host will send a Chargen request, and immediately after it starts receiving some arbitrary characters, a genuine client will stop the connection and not keep the connection open. Similarly, you can also send a Chargen request to a UDP port for Chargen, and in the case of UDP, the server is going to respond back with one single packet that has a random number between 0 and 512, a number of characters, and if the initiating client host gets such a packet, it will decide that the server is alive and running and not send any more such packets. So it's just a genuine client is going to send just one packet to find out whether the other machine is alive or not. But what an attacker could do with such a protocol, the Chargen protocol, is now, in addition to the Chargen, here the attacker will also exploit the Echo protocol, which is the ping protocol that we just saw. And the ping protocol runs on port 7, and the Chargen protocol runs on port 19. Now this is what the attacker will try to do. He will so let us say there is a machine, host A, running this Chargen protocol at port 19, and there's a host B that is running this ping protocol at port 7. Okay, so an attacker will send a spoofed IP packet that appears to come from host B, and the attacker will send that packet to host A targeting port 19. So what host A thinks is some packet comes to its chargen service, so it should respond back to the sender sending a reply to let the sender know that it is that host A is alive. But host A will now reply to who? The sender of this chargen request. So it is spoofed to come from host B. So and also the way the attacker will spoof that packet is he'll make the packet to appear to come from host B and port 7. So you all know by now that you need a IP address as well as a port number for a packet. So the attacker will make the packet to appear to come from host B, and the source port is port 7, which is the ping protocol. And the destination IP address is for host A, and the destination port number is port 19. So that's the kind of the source IP, destination IP, and source port number and destination port number. So the reply will now be sent by host A to host B, because that for A, host B appears to be the initiator of the chargen request, and it will reply back to the same port that sent that request. So it will reply back to host B at port 7. But think about it, port 7 is an echo request port, this ping port. So host B will now respond back with an echo reply to whoever sent it. So that request appears to be to come from host A at port 19. So B will reply back to port 19 at host A. Now for A, it will again look like a chargen request coming to port 19 from host B. So it will reply back to port 7, the source port. So it means the attacker now has successfully initiated the flooding of packets, the exchange of packets back and forth between A and B. So they will keep on exchanging this chargen and echo request reply packets, and eventually the network at which A and B are running will be flooded with those packets, and the networks will be brought down. So this is again a denial of service attack by exploiting the echo and chargen protocols. Okay, so any questions? So let me save up to this so far.